All right, so before I can go to StatKey to try and get this calculation, we need to write some stuff on paper. This is number 17 from practice week 8. And the important things here are the mean of the population, mu, the standard deviation of the population, sigma, and the sample mean, and the sample size, n. Here they want a probability that the mean is less than a particular number. So that means I have to use the central limit theorem. Central limit theorem says you have to adjust the standard deviation by divided by the square root of n. So I have to take that 1.56, divide by the square root of 31. So then my picture, so I don't have this picture, then I don't know where things go in StatKey. Put the population mean always in the middle, 8.9. And then we have to figure out where the sample mean goes. So this right here is my mu, and that is smaller, so that's going to be somewhere in this range over here. So let's guess 8.5 is around there. And if you want to know more precisely where it goes, you have to use the standard deviation to count standard deviations to the left or right. So I'm just guessing it goes right there. So this right here is my x bar. And I want to calculate that value right there. That's going to be my probability. And in order to place this properly, I need to know what that value is. So then we need a calculator and StatKey. So quick sketch, then calculate. So earlier I calculated that to be about 0.28-ish, and I'm just going to grab all of those decimals to be a little more accurate. And then in StatKey, just reload this page and start over. You have to enter your mean. That's the population. Standard deviation, because we have a sample here, has to be the adjusted one, not the 1.56. And then we have to decide, is this a left tail, a two tail, or a right tail? And we were asked to find the probability that it was less than, so that's a left tail, less than left tail. That's our alternative hypothesis, if we wanted to talk about hypothesis tests. And so then down here is where the sample mean goes. So in this case, the x-axis is all about averages. So the population average is in the middle, and then we answer a probability based on the sample. And so this would be the 8.508. And then this number right here is the probability of finding another sample of 31 cigarettes that has nicotine levels on average of less than 8.508, which isn't rare if we were expecting the average nicotine to be 8.9. Okay, so there is the StatKey calculation, which is way easier than the spreadsheet version. But the spreadsheet is sometimes necessary because I might need more decimals, especially if it's a rare event. And this one is not rare. So does it appear the nicotine is lower on average? The answer is nope, it does not. It is can happen by just natural chance that you'll get a pack of cigarettes that has a nicotine of 8.5 when we were expecting it to be 8.9. So it doesn't appear they did a good job of lowering the nicotine. Okay, so let's stop that there.